Okay, let's talk lenses. So we're going to talk about curved lenses, convex and concave. A convex lens is also known as a converging lens. You may see it on some homework problems as a converging lens. And then a concave lens is known as a diverging lens. Okay. A convex lens is thick in the middle, and a concave lens is thin at the middle. The students tell me they remember it because they say this one caves in. Because it caves in right here and right here. So the concave caves in, and the convex is the other one. Now, we've got our real image. Okay, we've talked about virtual images, but now we're starting to talk about real images. So real images are formed with converging light rays. You can see all these lines, if they're light rays, okay, when they pass through that lens, that didn't work very well. They are all supposed to be converging on the same spot right here. I just can't draw very well. Okay, so a real image is converging light rays. And this is not true. They're not always on the same side. Okay, so they're converging light rays. Now, a virtual image is an image formed by diverging light rays, and it's not always on the opposite side. I was trying to make it easy, but it's not true. So don't write that part. Okay, so here we have all of our light rays. They're going through, and then they're diverging. Okay, a virtual image, diverging, real image, converging. So, a convex lens. Now I'm going to teach you how to draw these ray diagrams in a different video. But there's a couple different locations where if an object is at different locations, it's going to have specific characteristics relative to that location. So this first location we're talking about is twice the focal point. Okay, the rays are going to converge. If they're converging, that means you've got a real image. So this image right here, we see these lines, right? They're converging at that image, so we have a real image. Okay, this image is upside down. They call that inverted. Okay, you can write upside down if you want, like on your tests and quizzes or whatever. I'll give you credit for that. Upside down. And then the image is smaller. Okay, and you'll just draw two rays. You'll draw one. It goes horizontal till you hit the lens, and then it will go straight through the focal point. And then you'll have another one that'll go straight through the focal point and then go horizontal. And where those two meet is your image. And you just draw your image like this. But we'll do some ray diagrams. Okay, and this is if the object is farther than twice the focal point. Now, if we have the object exactly at 2F, the rays are still going to converge. Okay, so this object is right at 2F. The image is going to be right at 2F. The rays are going to converge. Okay, so that means we're going to have a real image. The image is still upside down. We call that inverted. And the image is the same size. This is the only place where the image is at the same size on a convex lens, and this is if the object is exactly at 2F, the image will be exactly at 2F. Okay, so you're going to draw that horizontal line to hit the lens, and then go through the focal point on the opposite side, and then you'll draw a ray that goes from the object to the focal point on the same side as the object, and then a horizontal line, and where those two meet, that's where you're going to have your image. Now, if you have an object directly at the focal point, you will get no image. So they don't have one for here, but I'll write it for you. Object at F equals no image. And you're going to do a lab with this, okay? And you're going to get no image, and you're going to freak out, and then hopefully you'll have written this down and you'll see that that's okay. Okay, so you will get no image at F. If you say on your lab that you get an image at F, you're going to get it wrong, okay, because I know for a fact you didn't see an image. So now we have closer than the focal point. This is going to cause the rays to diverge. So you see this object, he's small now, and he's closer than the focal point. To do this, you're going to make that horizontal line, and you're going to send it through the focal point on the other side, and then you're going to do like dotted lines back, okay? And then you'll start one at the focal point, and it'll go through the focal point, hit the top of your object, and then go through, hit like the center of your lens, and then you'll draw a horizontal line. These two, you can see they're diverging. So in order to find the image, we kind of have to like back draw them. And so you see that's what they've done here. So this image is virtual because it's caused by diverging light rays. It is upright, and it is larger. This is what's going on in the projector in the classroom. You have this really tiny object, and they reflect it off a lens, and it makes a really big virtual image, and it shows up on the projector screen or on the wall or whatever. So here's just a table. It's in your book, and it kind of it goes ahead and it puts everything in a table for the convex and the concave. But we just did convex so far.